Okay, so today what we're going to do is we are going to continue our lesson on graphing. And so 7.2 is all about something called graphing lines. Okay, so what is our equation going to look like? So it's going to look something like this. Y is equal to 2x plus 3. So notice that we have two variables, right? So we're only used to seeing equations with one variable, but now we have two variables in our equation. So that means that there are going to be two numbers that are required, right? Required for a solution. Okay, so that those two numbers are your ordered pairs, right? So those two numbers we call your ordered pair. Has both the x and the y coordinate, which we've plotted before. So an example of this would be, say, 5, 13. This is a solution to this equation. Everywhere I see a x, I'm going to plug in 5. Everywhere I see a y, I'm going to plug in 13. So 13 is equal to 2 parentheses times 5 plus 3. So 2 times 5 is 10. And notice that 10 plus 3 gives me 13. So that is a true statement, right? But there isn't just one ordered pair that works. There are several ordered pairs. So I found another one that works. 0, 3. So let's test this out again, x and y. So 3 is equal to 2 times 0 plus 3. So 2 times 0 is 0. So 3 is equal to 3, right? Both of these are solutions. That's what we're going to call solutions, right? That's a solution. That is a solution. Okay, so notice that there's not just one answer, which is kind of cool. We're used to equations that just have one solution. So that means that there are actually a lot of solutions. There's actually an infinite amount of solutions. So there are infinitely many solutions for a linear equation. Right? This is a linear equation. Notice the key word in linear is a line. So this will graph like a line. So what do we do, right? So how would you actually come up with these numbers? 5, 13, 0, 3. Well, let's walk through our first example. So example number 1, let's actually put it in black. So example number 1. We are going to graph this equation. Y is equal to 2x minus 3. So how do I do this? Well, the first thing that I want you guys to do is I want you to make a table. So make a table and choose x coordinates. Looks a little sloppy. So let me erase that. X coordinates. So choose x coordinates to plug in to find the y coordinates. That's the first thing that we're going to do. So let's make a table. This is what we're going to do. So x and y. So you can choose any numbers that you want. Just have to remember that you are going to have to plot these points. So for right now, I suggest plugging in coordinates that are pretty close to the number 0. So I wouldn't choose, say, like 100 or negative 50, because you have to make your x-axis and y-axis much, much bigger. So let's try negative 2. So that's a good number to start off with. So what does this look like? So y is equal to 2 times negative 2 minus 3. So 2 times negative 2 is minus 4. So y is equal to negative 7. There's an ordered pair. Let's try 0. 0 is always a great number. So y is equal to 2 times 0 minus 3. So 2 times 0 is 0. And we get negative 3. Not bad. I'm going to choose 1. So that's a good number to have. So y is equal to 2 times 1 minus 3. So this will give me 2 minus 3, which is negative 1. So I still have all my outputs are negative, so let me get a little bit bigger. I'm going to choose the number, let's choose 4. Let's see what happens with that. So y is equal to 2 times 4 minus 3. This will give me 8 minus 3, which is 5. Not a bad number to have. So these are our ordered pairs. Let me do this in a different color. Oops. Erase that. So we are going to plot negative 2, negative 7. We will plot 0, negative 3. We will plot 1, negative 1. And we will plot 4, 5. So technically, we just needed these first 2 points in order to make a line. 3 points make a better line, and 4 points or more make an even better line, right? So my suggestion when you are walking through this is you must have at least 3 points. So let's add that to our list, right? So make a little note, must have at least 3 points. Right? Don't have any less than that. All right, so what do we do after we make a table? We find our points. We are then going to create an x-axis and a y-axis. So create with a ruler an x-axis and a y-axis. Okay, so let me get graph paper. So we can add that to our list on graph paper. All right, so I do have some graph paper. So create with a ruler, an x-axis, and y-axis. Now, unfortunately, I do not have a ruler with this, so we will try the best I can to make make straight lines. So here is my y-axis, and here's my x-axis. Oops. Let's make it a little bit better. Oh, I'm just messing this up royally, aren't I? All right, let's erase part of that. Make it a little bit better. Okay, that's a lot better. Great. So this is our x-axis. You do not necessarily need to tell me that it's your x-axis. Up here is our y-axis, right? Our origin right here, 0, 0, which means that this is 1, 2, 3, 4, 5. We're just labeling points. This will be 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, negative 1, negative 2, negative 3, negative 4, negative 5 is down here. Okay, so what's the next thing that I want to do? So we have created, with a ruler hopefully, an x-axis and y-axis on our graph paper. So the next thing we're going to do, step number 3, is we are going to plot each point. So plot our points. So our first point is, let's start at the bottom, so 4, 5. So 4, 5, so 4. So I'm going to start at the origin, 1, 2, 3, 4, 1, 2, 3, 4, 5. So make a dot right there. Next number, 1, negative 1. So go over 1, go down 1. Next one, 0, negative 3. So 0, don't go left or right. 1, 2, 3. Right? Now, unfortunately, on my graph, negative 7 is not going to necessarily plot. So I'm not going to plot that last number, which is fine. But if we went, we'd be negative 2, and we're going to go all the way down to 7. So it'd be off my paper way down here. So after you plot each point, step number 4, you are going to connect the points using a ruler. Using a ruler. Okay, so connect the points using using a ruler, and we are going to kind of a little side note on here. You want to extend the line through all points. So I don't want to stop here, right? And I don't want to stop here. So I want to go through because we could have picked 5. Notice that -2, -7 was a solution, but it's not on our graph. So we want to extend it through everything. So let's make it a blue line. Again, I don't have a ruler, so the best of my ability, right, is going to look something like, oops, bam. It's going to look something like that, right? You're going to draw arrows at the end to show that our graph continues on for forever and ever. Okay, and that's all we have to do to plot our points. So what I want you to do is you are going to try a few examples on your own. Okay, so come back to normal white paper. So the video will be over at this point, so I want you to try the next 2 examples. So example number 2 is going to look like this. So graph y is equal to -3x plus 5. So try that one. And example number 3, again, graph y is equal to x plus 4. So remember, you are going to make a table, choose some x coordinates to plug in to find the y coordinates, must have at least 3 points. You are then going to create with a ruler an x-axis and y-axis on graph paper. Then you're going to plot each point, connect the points using a ruler. Your line should be much better than mine. And then you want to extend the line through all your points. So notice that I did not stop here. I went through as if my graph was going to hit -2, -7, and I kept going through here. And you're going to extend your points. Once you have done these 2 examples, I want you to watch the second part of this lesson, and it'll walk you through these steps.